Alright, I thought I'd make a little bonus video for you since, I was so mean about that quiz and everything. So here is the stuff that you asked in homework that we didn't have time to go over in class. Somebody asked about number 17, and I was in the room. Well, we had I guess it was lunchtime or something, and we did this one. Oh, you can't really see it all. The window changes sizes. That's not fair. Okay, so I don't know. Does that help? Can you see it all now? I'm gonna have to change how I do this, I guess. Anyway, number 17 was not the first one that was asked in order of problems. Just the first one that was asked of me. There's a couple of ways to do this. I've done one way. I'll try another way. Okay, now I have to move this just so I can get the pen. Let me talk about this one, and then I'll start writing. Alright, so it was find the area of this yellowish band in the middle of this circle. And they give you the fact that this is 2 and that this is 120 degrees. So sorry about the coloration on that. Since this is 120 degrees, you know this is also 120 degrees. I think they tell you these are congruent or something like that. Anyway, you know these are both. Maybe they tell you this is 120 also. Anyway, my point is, the trick here is to do this diagonal cross thing. And actually, there's a lot of ways to do this. We could have also instead made little vertical things here and had a rectangle and then the two little pieces that stick out from the rectangle. Here, what I decided to do was, well, here's two different plans right here. One is to chop it this way, and I get 2 sectors. See, this is a sector. It's a pizza slice piece here, and then I have 2 triangles. 2 identical triangles, one here and one up here. The other way to do it, which I already did, was when those people were asking me at lunch, was take the area of the whole circle and subtract off these not highlighted orange things, and then what you're going to be left with is this middle band. Let's talk about that first. First of all, I know the radius of this circle is 2. They don't tell me it's 2. They tell me this height is 2. But when I chop this way and this way, I know this angle in here is 120 degrees. Well, if that's 120 degrees, and I chop it in half, that makes this 60. If that's 60, this is a 30, 60, 90 triangle. And if this height is 2, I know this height, ooh, that's cool. This height would be 1. There's a height of 1 here. So if that's 1 and this is 30, 60, 90, this is 1, this has to be 2, and this has to be, this side down here has to be 1 times the square root of 3. So it's all because this is 120. I know the relationships in these right triangles here. So if this is 2, this is have to be the radius of the circle. So the circle's area is pi times r squared. The little sunrise pieces here, these orange things sticking out, are going to be sectors, this size sector here from the center up to this arc, this whole sort of fat pizza wedge piece, minus this lower triangle. So I have to find this triangle area in either one of these methods. The whole fat sector area thing is not bad. It's 1/3 of the circle because it's 120 degrees. And then the triangle piece, I've already got this one marked, so I'll talk about this one, is a half times base times height. The base is 2 square root of 3 from here all the way over here, and the height is 1. So here's area of the circle, and here's area of the sector minus the triangle. So 4/3 pi minus square root of 3 is actually the area of this orange sunrise shape out here. There are 2 of these, so I'm going to take that times 2, 4/3 pi minus square root of 3 times 2 to get all the orange area and subtract it from the circle, and I get something that looks like this. The book has a different looking fraction. They have, like, they distribute out the 1/3, and they have different numerators, but it's equivalent to this. I kind of like my version better. All right, let me move this up, and then so I can select the pen again. What a dumb problem. Okay, I mean a dumb issue to have on the computer. It's not a dumb math problem. It's fine. Okay, another way to do this is method 1. Actually, is to take add up 2 sectors. So add up this actual sector here and this actual sector here, and 2 triangles. The 2 triangles I already had. You know what? I can sort of cheat. I already know the area of these triangles. The triangles are, whoops, I don't want to write in black. A half times the base, which is 2 square root of 3, which we just did, times the height of the triangle is 1. Now there are 2 of them, so I'll say 2 times that. And to that I'm going to add the 2 sectors. Well, the angle in here would have to be 60. If this is 120 and this is a diameter, this has to be 60 over here. So I have a 60-degree sector. I think this method's actually a little easier. 60 degrees of pi r squared I know what r is already. It's 2. And there are 2 of these. Right, there's one over here and there's one over here. So I add up all this and I should get it. 2 times 1/6 times 4 is, guess what, 4/3 pi. And the thing over here, the 2 and the half cancel. I have 2 square root 3, which is what we had before down here. Okay, great. I'm going to change this window size before I do the next one. All right, 13 looks something like this. We know this is a right angle. We know the radius is 4, and the area we're actually supposed to find is this thing out here. Well, the quarter of the circle wouldn't be so bad. Just, this entire red sector would be 1/4, because it's 90 degrees. You call that 90 over 360 of pi r squared, which is just 4 pi. And then, right, 1/4 of 4 squared is 16 divided by 4 is 4. Yeah, and then I need to take out this part. That part can't count. So I have to take 4 pi and subtract the area of this triangle. And the triangle, this would also be 4. So the area of the triangle is 1/2 times base times height, which is 8. So the area of the yellow thing is 4 pi minus 8. Now the book, again, has been really sloppy about when to use exact, when to use approximate. I think you should get in the habit, because of what I know about you as a group. Get in the habit. If you can do this, great. If you need to use decimals, try to hold off as long as possible hitting the pi button or hitting the square root button. There was no reason why I had to use a decimal for this in order to figure this out, or anything else I need to write down. So I'm just not going to do it. So there you go, number 3. 14 is very similar. They give you the okay, that's really big shading. They give you the radius of the circle. They give you that this is a 60-degree arc, kind of like giving this as a 90-degree arc, and they ask you to find this. So we're gonna do the same thing. We're gonna find this entire sector, and we're gonna subtract out the triangle. We have to do this a lot. The sector is 1/6, because that's 60 out of 360. It's 1/6 of pi r squared. That's 9 divided by 6, which is 3/2 pi. And then I need to take out the triangle. Now the triangle here is a little bit yuckier because it's equilateral triangle. It wasn't as nice as the isosceles. I need to know the height of this triangle to find the area. Well, if this is 3, I can cut this in half. This is 1.5. This is 1.5 square root 3. We do this a lot this time of year. You should be used to that by now. So the triangle is 1/2 times that base times that height, which in my calculation is 2 1/4 square root 3. Now I have a decimal here. That's still exact because it's a nice terminating decimal. I use 1.5. I could have used 3/2. I use the fraction here, decimal here. I'm a little sloppy. Anyway, I should probably make those all the same. This is also the same as 9/4 square root 3. You could have done that way too. If I would have used 3/2 here and here, I would have seen that. And I'm just realized I had fractions and decimals in the same. That's a little bit tacky. Okay, so I want to take this minus this. My plan is take the area of the sector to 3. 3/2 pi minus 9/4 square root of 3. Now the book has something fancier, well, not really fancier, something different. They have 6 pi minus 9 square root 3. Are you kidding me? Over 4. Yes, this is the same thing. If you think about it, well, here's your 9 square root 3 over 4. 6 pi over 4 is 3/2 pi. I don't know why they do it this way and I do it this way, but they are the same. 15 is a little different in the fact that they want you to find all of this. They want you to find the sort of major part of the circle, and to me, I think what that means is we're just going to take the whole circle and try to subtract off that other thing. The other thing that's weird is they give you the width of the circle. Like, what? Why did they give me the width of the circle? That just means that the diameter is 8. So that means that the radius is 4. So that's great. And you notice we're doing this a lot. We're taking the sector kind of thing, and we're chopping off a triangle. That's the same thing we did here. Oh yeah, they also tell you one more thing. They also tell you this is 90. So this is starting to look a whole lot like number 13. In fact, I'm going to use number 13 to do it. I know the area of that triangle is 8. See how we can capitalize on that? So again, I'm going to take entire circle minus this little piece right here. You know what? It wouldn't be that bad. I could actually add this up. I could do 3/4 circle. I could do this Pac-Man thing plus this triangle. There's nothing wrong with that. I don't know. Maybe we should do that. Let's try that. 3/4 circle, which is I just said 3/4 of the circle 3/4 of the circle plus the triangle. Half times 4 times 4. 4 and 4 are base and height because it's 90 degrees, so that's nice. 3/4 of 16 is 12, and half of 16 is 8. There you go. That's exactly the way the book does it. All right, here I'm on 16 now. I'll try to reduce this so when you're watching the video, you can kind of see what's coming up. All right, in 16, I want you to find this area sort of together with, gosh, can I get in there and just highlight this? This area here, they want you to find those two things all together. Well, again, there's a number of ways you can think about how to do this. You can think about taking the whole circle minus the half circle minus the triangle. You could take this little sunrise compared to, and add it to this little sunrise. I think it's going to be easier to do, let's do half circle, and we'll take out the triangle. This is nice, it's a 30, 60, 90 triangle. I know this side, that's a radius, that's got to be 12. This side also has to be 6. This side, in case I ever need it, would be 6 square root 3. That's kind of nice. The radius of the circle is 6, so the half circle is half of pi r squared, so that's 18 pi. And by that I mean this whole section here is 18 pi. You know what? I've been bad about this. I will say it this way. Half circle, that's what I'm finding there. And then let's find the area of this triangle, and we'll subtract. Half circle is 18 pi. Triangle is a half times base times height. 6 times, because this is a right angle, correct? Half circle connects to the circle. It's got to be a right angle there. Times 6 square root 3, which is 18 square root of 3. And then I would just subtract those to get what I want. 18 pi minus 18 square root of 3. No reason to do anything other than that, and there's nothing I can combine here. Those are unlike terms. Done. Okay, in 18 they tell you these things are all 6. It looks a lot like 17, which I already did. They tell you that those are all 6, and they're asking you to find the area of this middle sort of stripe that goes across the whole thing. And the trick is going to be the same. We're going to divide this up like we did in 17. Actually, this one, if you think about it, we could... if you think about this length here that's also 6, you could move this in here. What we really have in here is a square inside the thing. You could think about a square. You know what? It's not a bad idea to think about a square. You could chop it up into a square. You could chop it up with these diagonals, like kind of like this method. Those are that way. Since I know that's 6, yeah, I'm going to go ahead and draw these two. Do I want to do that? That might confuse you. Okay. So, here we go. We could do the 2 sectors plus the 2 triangles. That'd be fine. Or we could do the whole circle minus these 2 little bits. But to do that, you got to find these anyway. I'm gonna do the adding way. I'm gonna do the 2 sectors first. Oh, first of all, to do the sector, I need to know the radius of the circle. I need to know this angle. Well, if this is actually a square, and it is 6, 6, 6, 6, the only thing that's going to fit in there is going to have to be a square, not a rhombus. So I'm pretty sure this is a square. I am sure this is a square. Oh, here we go. Equal chord has to be equal angle, equal angle. All 4 have to be equal. It has to be right angles. So there you go. There's your proof. This is a 45, 45, 90 triangle here, or this is a 45, 45, 90 down here. So if this is 6, this has to be that divided by the square root of 2, which, if you're careful, you'll figure out is 3 times the square root of 2. So that's the radius of the circle. So what I have here is a quarter of the circle. And I really have 2 of them. So let's do the 2 wedgy things here first. That's going to be, finding that area is 2 times, because there's 2 of them, 2 times a quarter, because it's a quarter circle, times pi r squared, which is 2 times a quarter is a half. 3 square root 2 squared is 3 square root 2 times 3 square root 2, which is 9 times 2, which is 18. So this whole, the 2 sectors added up is 9 pi. Then I want to find the 2 triangles. 2 triangles. I'm going to add these up. The triangles are, this is the radius of the circle. So this is 3 square root 2. This is 3 square root 2 also. So 2, because there's 2 of them, times a half times 3 square root 2 base times height 3 square root 2, which I just found out was 18, and those cancel, so this is 18. So I'm adding the whole thing up. I get 9 pi. I don't know why I always put the pi's first, but the book does too. 9 pi plus 18. There we go.